To protect the climate, we're changing in ways that might surprise you. We've turned to the most experienced fluid dynamics experts in the world to make airplanes more efficient. We're planning a heat pump the size of a soccer field to reduce our own emissions. Blazing a trail with recycling technology to breathe new life into old electric vehicle batteries. And to power our own factories. We're building an offshore wind farm, the biggest in the world. To protect the climate, we're changing, getting inspiration from all kinds of places and all kinds of people.
Hello, everyone, and welcome to our Sustainable by Design event series. Thank you all for joining us. My name is Ben Klovatsky. I'm the Sustainable Business Strategy Manager for BASF, and I am your host for these event series. So very excited that I can say we've had over 1,000 people register for this particular event. So we've seen some very good registration, and that tells us that there's a lot of interest in our topic. So thank you for your interest. Thank you for being here. Sustainable by Design is an event series that we are hosting during this month of April to bring sustainability awareness to the forefront. We want sustainability to be at the design phase at whatever product or service is brought to market. So really the concept we're putting forward is let's design with the end in mind. Our sessions have, they actually started on Tuesday, so we had 2 sessions. This is our 3rd session. Today is about designing packaging that is intended to be recycled. So thinking about the end of life at the beginning. So just some very brief housekeeping items. We have a jam-packed agenda today. We've got a lot of information. We've got some great speakers, so I'm excited about that. So I'm not going to take up too much of your time at the front here. For those of you joining or a repeat customer, I would say, if you've attended the events on Tuesday, then you know this information. But for those of you just joining today, on your console, there's some information. There's some speaker information on the right-hand side, as well as additional resources. So in some cases, any downloadable content or links, anything like that would be on the right-hand side in that box. We do have an opportunity to ask questions, so as we're going through the presentation, you're welcome to type those questions in. We will try to answer as many as we can. We've had quite a bit of participation over the last month, so always running short on time, but we do try to be respectful with everyone's time and finish right at the top of the hour. But please get your question in. We'll try to answer it. If we can't during the event, then we'll answer it afterwards. Also very important is we do have a survey. Now, the survey is a little bit hidden. On the bottom of your screen, you'll have a few boxes or icons. The one on the far right is the survey one. So we very much welcome your input. There's an opportunity to either ask a question there or to reach out to us if you'd like to be contacted. So I think that's all that I have today. So we have this session in the morning. We do have another session in the afternoon. So it's afternoon on the Eastern time zone. So please attend that. But without any further ado, I'd like to turn it over to Brian Schmatz.
Perfect. Thank you so much, Ben. So I really appreciate the time everyone took today to come join us on this topic that's really important to myself and everyone here on the call, which is designing packaging that is made to be recycled. So I've got myself from Trinamics, which I'll talk about as an offshoot of BASF, Tina Wickman from Church & Dwight, and Tyler Matusevich from Brook & Whittle. We've all been working together for a little over a year now, I believe, on this topic, and I really appreciate BASF giving us this forum to really present the kind of multi-stakeholder work that goes into addressing some real-world challenges like this. So I'll start just with myself with a quick introduction. So my name is Brian Schmatz. I lead the Trinamics North American activities. I got my PhD in polymer chemistry about 5 years ago from Georgia Tech, where I worked on print electronic applications. From there, I went on to BASF, and I just like to mention the 3 roles I've had at BASF as a Effect Pigments R&D scientist, a corporate sustainability specialist, and then leading into my role here at Trinamics. Because I think unknowingly, I built up a perfect set of skills to talk about this topic of packaging recyclability everywhere from pigments to the sensors themselves. So Without further ado, Trinamics itself, as I mentioned, is a 100% subsidiary of BASF. We are their optical imaging components part of the business, and since we make hardware and software, which isn't a typical BASF practice, we were spun as our own brand name under Trinamics, but for all intents and purposes, we are a piece of Trinamics. And we've got a few different sides of our business, but I think the one most important to mention on this conversation is our mobile spectroscopy solutions platform. And so we've got a handheld near-infrared spectrometer. I can show it here just to give you a little sense of size. That comes with a smartphone app and a cloud analytics platform to provide instant analysis of plastics identification. So everywhere from collectors to brokers to recyclers, and yes, even package designers can use our device anywhere, take a quick scan of a plastic and see what it's made out of. And to give you a little demo of what that looks like, this can really come in handy whether you're just at your home office like me here, scanning a Tupperware lid and seeing what it's made out of. So you can see, I can just take a scan and see that this is a low density polyethylene material. I can take my little BASF Playmobil toolbox and scan that and see its ABS. And so it's fun for someone like me in a home office, but it's also really powerful to see where this can take you beyond that. So since our device is portable, this can also take you to places like Alaska, where you're doing marine debris cleanup on a boat. And just right there out in the middle of nowhere, you can scan plastics right on board the boat, see what they're made out of, and effectively sort them there. And so we're really democratizing this tool across the industry. And it's something that's really brought me into this sphere with both Tyler and Tina. So I do want to turn it over now and introduce Tina Wickman from Church & Dwight. So Tina, if you want to go ahead and introduce yourself.
Hi, everyone. I'm Tina Wickman. I have a packaging degree from Michigan State University and worked for all of the companies mentioned here. My entire career has been within the packaging development space, and everything from sort of packaging design to process development, managing people, lab testing. And I spent most of my career, 16 years at Unilever, and but have made stops at all of these other companies, which I'm sure you recognize. And most recently have joined Church & Dwight about a year and a half ago in my first role that is dedicated to sustainability. So if you could jump to the next slide, Brian. So Church & Dwight, you may not know the name Church & Dwight, but you know many of our brands that you'll have within your home. So we have lots of home care, personal care, cat litter, and hair care, lots of different things. So you'll recognize the Arm & Hammer brand as one of our most prominent brands and well known. So this is just sort of an introduction into what we're doing, and we'll get further into some of our initiatives as the conversation moves forward here.
Perfect. Thank you so much, Tina. So next I want to introduce Tyler Matusevich from Brook & Whittle.
Yeah, hey everyone. I'm Tyler Matusevich, Sustainability Director at Brook & Whittle. Been here for coming up on 2 years now, but I got my start in sustainable packaging while studying packaging science at Virginia Tech. And I also worked there in the packaging unit load design center. Spent a good chunk of my career at UPM in their label division, which is UPM Raffletech, before continuing on to Digimarc and of course now at Brook & Whittle. As Brian mentioned earlier, we're all currently working closely together as part of an APR work group. APR, if you're not familiar, is the Association of Plastic Recyclers. Anyways, thanks Brian for the invite today. So a little about Brook & Whittle. We're one of the leading printing and converting companies in North America. And our focus is on these 4 decoration methods you see below, being pressure sensitive labels, drink sleeves, flexible packaging, and then heat transfer as well. And my goal really here at Brook & Whittle is just to embed sustainability throughout the business. And that's sourcing, that's operations, it's R&D, marketing, sales, and also serve as lead of our ESG efforts. So again, we'll get into a bit of that today.
Perfect. Thank you, Tyler. Yeah, so I wanted to get started by just framing the topic at hand. This series, Sustainable by Design, is really all about circular systems. And I wanted to frame the topic of why packaging is such an important thing to be considering when we're talking about circular economy transitions. And so just to start, if we look here in the US at the latest EPA facts and figures, about 28% of municipal solid waste comes from packaging. So that's about 82 million tons per year. And of that, about 54% is recycled. And so you can see there's a lot of room for improvement, or like we like to think of it, a lot of room for opportunity. And so what I put here is just an increase of every 1.2% can really lead to 1 million tons of recycled material added into our system per year. And so you can see it's a very big topic, but it's a real big opportunity where small changes can really have a huge impact. As part of this, I'm not the only one, and we're not the only one who see this as important. So there is a lot of legislation, a lot of NGOs working around this topic of how can we make packaging more circular. One of the leading voices here is the US Plastics Pact, at least here in the US. And that is an organization that is funded by the World Wildlife Fund, the Ellen MacArthur Foundation, as well as the Recycling Partnership. And they laid out this list of goals a few years ago. And really, they started with just defining what are problematic materials in the packaging industry. And that list you can see here is on the right, everything from small single-use objects like cutlery, stirrers, straws, but then kind of more technical feats like no PFAS materials, no non-detectable pigments, and we'll get into that topic later, problematic label constructions, which we'll also get into topic later. So they put this list out there, and they're working as an organization with all of their stakeholders to eliminate these items by 2025. And with that goal is to bring 100% of plastic packaging to be reusable and recyclable or compostable by 2025. And then they want to achieve, effectively recycle or compost 50% of plastic packaging by 2025. And then as another goal, achieve 30% of post-consumer recycled material in packaging. So you can see various goals here, but really all centered around addressing what are the issues in this industry affecting recycling rate and what can we do to drive change in the next few years. I do want to take a step back and make sure everyone's on the same page of what our recycling infrastructure looks like here in the US and the supply chain. So starting from virgin plastic pellets, those are then sold to converters. So this can include the people making the bottles or containers themselves, but also people like Brook & Whittle making the labels, working in unison with brands to design packaging for a consumer packaged goods product. That then makes its way to a consumer who will then hopefully put that into a recycling bin that's collected by a local municipal collection agency and brought to a place that's called a MRF. It's a materials recovery facility whose main job is really sorting everything. So most municipal recycling programs will include plastic, glass, cardboard, and paper, and it's the MRF's job to separate all of those materials so they can make their way to separate reclaimers who then take that material and process it back into new materials which can be used as inputs as an analog to virgin pellets. And so there's a lot of steps here, and I wanted to just make sure we're all kind of on the same page. And while I think a lot of focus really goes into that consumer side of how can we make packaging more obviously recyclable, open up access to recycling for more consumers, and advocate for more consumers to recycle. While these are important topics, we really want to focus on this second section here, which is collection, materials recovery, and reclaimers. And so here we can really think about how do we make sure a package is actually recycled once it's dropped off by a consumer. And to give you a quick snapshot of what this process looks like, because it's easy to think of a MRF as a black box, what I'm showing here is pictures from Sims, which is the largest recycling facility in the US, located here in Brooklyn, New York. And this is really just one of 6 dumps that they do for a day of barges coming in from all the boroughs in New York City, dropping off this recycling and then making its way into the MRF sorting line. And so from the truck dropping it off, we've got a few different sorting steps. You've got a 2D versus 3D screen. So this will mostly look to separate out cardboard and paper from the bottles and other 3D containers. We'll then go through a series of magnets and eddy currents to get aluminum cans and other metals. There will then be an impact stage, which will then crack glass and collect glass. And then you've got optical sortation, which will then sort out the various different plastic types. You may know the 1 through 7 codes that you see on consumer packaging. The optical sorter will be responsible for sorting out these plastics, and then everything else that does not make it through this line makes its way to a landfill. Now, just focusing in on one plastic stream, if we think of at the end of the day, they'll come out with bales of PET, HDPE, polypropylene, etc. If we follow just one of those PET bales, this will then go to a PET reclaimer who will bring it through its own sorting line of delabeling, bringing it through a color sort to move to different colored materials and segment them that way. A granulation step so that they're chopped up and ready to be brought into resin. And then a float sink test to get out some contaminants, small things like caps that made its way through that aren't PET. And then at the end, you've got post-consumer recycled PET flake. So just wanted to show you this is a very complex system, and there's a lot of steps, which unfortunately means there's a lot of steps for things to go wrong. And so when we talk about designing for recyclability, there's really this first step of, is the material recyclable? And if it's made out of PET, yes, it's recyclable. But there's a bigger question of, is it getting recycled in our current infrastructure? And that's what we really have to think of when we're designing for recyclability, is will that package I create make it through all the steps that we see here on this page? And so with that as a starting point, I really wanted to pass the ball over to Tina and ask, can you tell us a bit about current trends within the consumer packaged goods industry on circularity and on sustainability?
Yeah, of course. So, excuse me. So some common, I would say the most common packaging sustainability goals across CPG companies are listed here. And these are very much aligned, I would say, across pretty much all of the CPG companies. They have some version of this. Percentage of reusable, recyclable, or compostable packaging by a certain date. A lot of companies are going for 100% here, but that's, a really lofty goal. 95% is usually most realistic. Then we have recyclability labeling. Companies are making commitments to label all of their packaging with some kind of instruction on recyclability. Then we have a post-consumer recycled content, specifically in plastics. There's minimum percentages that companies are striving for. A lot of them are, about 25% is what they're setting their goals at for in the next 2 to 7 years. Reduction of virgin plastics is another goal. And then free of problematic materials. This kind of harkens back to what Brian mentioned about the U.S. Plastics Pact, the list of problematic and unnecessary materials. So now that companies kind of know what they're going for, since this list was released back in January, a lot of companies are looking to that list. And also there are laws coming out that are banning certain problematic materials. And when we say problematic, we mean problematic in the recycling stream. It's either a contaminant or if you did recycle that material, there's not really a market for it. There's no customer. So, it would be obviously better, ideal to go for to use plastics that can be recycled and have a market for them later, and ideally into more plastic packaging. The last one about sustainably sourced materials is really mostly around paper-based materials that like sustainably managed forests for making paper, corrugated, that sort of thing. Goals always should be quantifiable, a specific number or percentage, and they should be time bound by a certain date. And so that's pretty much where we are on the goals. But I'd like to talk for a second about what's driving these goals. Where is this coming from? So I'd say retailers and consumers are increasingly interested in more sustainable packaging, and they're expecting manufacturers to provide those solutions. Now, from a manufacturer's point of view, from our point of view on the CPG side, sometimes using more sustainable materials, let's use PCR, plastic resin, for instance. It can have a higher cost to it. But in the end, it can be worth it for the brand to spend a little bit more on that to do the right thing from an environmental standpoint. Why is that? Retailers, they're not only increasing requirements for their suppliers, which is the CPG companies, but they're also providing incentives around sustainable packaging. So retailers are awarding things like special labeling, premium shelf space or location in the store for items that qualify as sustainable under their definition. So not only do brand owners have an incentive to compete as a retailer, they also have an opportunity to build a reputation with the consumer as an environmentally responsible company. So we're seeing more and more CPG companies taking that stance that sustainability is good for business. For companies that they're still not so motivated in this space, or they're on the fence about spending that extra cost, legislation is helping to force the issue and speed up the activity. So these kinds of laws have been around for a long time in Europe and Canada, but now we're starting to see in the U.S. the introduction of more bills, laws that are passing state by state around EPR, extended producer responsibility. So CPG companies being the producer, we're responsible for now through these laws. There's a few facets to them. They might include sort of a pay-to-play approach. If you want to sell product into our state, then you're going to be responsible to help pay for the infrastructure that helps collect that waste and sort it, et cetera. So based on the tonnage of plastic that we would sell into a certain state, we would be responsible to pay, a certain amount towards that state's recycling infrastructure. Another part of those EPR laws would include PCR minimums. Like if you want to sell your product here, you have to use a certain minimum amount of PCR in your packaging. Otherwise, you'll pay a penalty per tonnage. Problematic materials are also being written into these bills, banning certain materials. For example, California has banned expanded polystyrene, otherwise known as styrofoam, for packing material. So that will no longer be allowed in California. But so in the end, the truth in labeling is really like it's really important, and where that comes into play is policy aims to standardize labeling and prohibit misleading, confusing, or conflicting direction. Because we can't expect consumers to do the right thing when there's such a wide range of recycling access and capability around the world and so many conflicting messages. So it's up to us as product manufacturers to be truthful in our messaging and help educate the consumers on PAC and elsewhere about what can actually be recycled, not just technically recyclable, like Brian mentioned. Sure, PET is technically recyclable, but will the end product actually go through the stream and be recycled?
Perfect. Thank you, Tina. Yeah, so Tyler, switching the question over to you. So based on what Tina said, do you see similar trends in the labels industry? I imagine there's a close tie between what CPG companies want and what label companies are looking to do as well.
Yeah, thanks for the question, Brian. Yeah, certainly you're going to see a lot of overlap between what I'm talking about and what Tina's talking about. And that's simply because the label industry certainly follows the CPG's lead. I mean, there are direct customers. So you can see a lot of those same themes in this holistic view of how we at Brook & Whittle approach sustainability. And this is pretty much true for much of our industry. It starts with that design phase and understanding what the brand's needs or goals are. And this is probably the most important aspect to get right, from my opinion, as it impacts the rest of that chain. So what we do is, we're designing for end of life while maintaining the functionality and branding that the customer needs. So that typically means all the R's are in play, as I like to say. So that's recycling, recycled content, renewable, simply reducing, or in some instances, reusability as well. So again, some of those same themes that you saw in Tina's slide and her discussion as well. And then lastly, we have to take a systems approach because we'll hit on later, and kind of Tina mentioned it as well just now, but not every package or material or component performs the same, and not every end of life is designed the same. So, maybe Tina can speak to this a little bit better than I can, but, as one package design or component changes, it does have a significant impact on the rest of your packaging, whether that's secondary or tertiary packaging, unit load design, transportation, or even how it appears on the shelf to the consumer. So I think like I said, there's a lot of different designs for end of life out there, as Brian's kind of hit on as well with the MRFs and the reclaiming environment. They're all designed a little bit differently and each have their kind of own nuances that we have to design around.
Great, thanks, Tyler. Next question for you again, Tyler. Can you speak to some overarching circularity goals specific to Brook & Whittle? So you just mentioned more of a holistic of the labels and converter industry, but I'm curious to hear what Brook & Whittle is doing on this.
Yeah, sure thing. So I just wanted to pull in some information about kind of internal sustainability goals, but are related to circularity. So what you see on the left side is those are our paper and plastic sustainable sourcing goals, which obviously has to do with designing for recyclability as well. And then you see some of our goals and operations. We released this a little over a year ago on our ESG commitment statement, which is on our website. And I can certainly say these are lofty goals. As you can see, they're our North Star, but we need something to strive for. But the good thing is that we are well on our way to certainly meeting the paper and plastic targets that you can see, which is in line with what we've been talking about. The majority of our papers today are either purchased as certified, such as FSC or SFI or PEFC fiber, or also contain post-consumer waste. On the plastic labels target, we're actually able to track our percent of sales that come from what we categorize as good, better, or best. And all of those good, better, or best classifications must enable recyclability of the final package that our labels are used on. And then as for the operational side of things, we actually recently begun calculating our scope 1, 2, and 3 emissions, which helps us identify some of those hotspots and areas to focus our reduction efforts on for our emissions. And then kind of lastly, what you see here is the internal metric on waste. We're working with different industry partners, waste solution providers on our path to zero waste to landfill. And have some exciting opportunities in this space over the next couple of years. I can tell you that this definitely hasn't been easy, both to create these, but also work towards achieving them. Not one bit. It's been very difficult, but I think the lesson here is that you have to start. You have to see where you currently are by benchmarking where you are, and you have to collaborate across the supply chain to collectively achieve sustainability goals. So yeah, just some of our circularity goals that we have internally at Brook & Whittle, but then also contribute to the greater system of packaging industry.
Thanks, Tyler. Yeah, I like that you mentioned the collaboration across the supply chain. And that brings me actually to my next question. So Tina, based off what Tyler just presented, that was the Church & Dwight circularity goals. Do you see these aligning with Brook & Whittle circularity goals? Do you see those aligning with what Church & Dwight is looking to do? And can you talk a little bit about how a company like Church & Dwight works with a label company like Brook & Whittle to have your sustainability needs met?
Sure. Yeah, absolutely. They're aligned. And that's purposeful because we work hand in hand with our suppliers. We, as CPG companies, we make the overall product, and what Tyler's company makes, labels, is a building block of that part of the sustainable design. So without suppliers like Brook & Whittle, who are those who have the latest technologies on recyclability, we wouldn't be able to meet our targets. So we definitely need to be aligned. If you think of these building blocks to put together a whole package, a label, a cap, a bottle, we can use APR compliant materials for a component, but we have to think of of them as just part of the overall design. We've seen instances where we put these building blocks together, we apply the label and the cap and the bottle together, and we run it through a MRF or testing an optical sorter, and it doesn't perform as we had expected. So we are learning together with our suppliers as we do testing for all the different combinations and scenarios of putting those building blocks together.
Thanks, Tina. And beyond, I guess, the labels topic and this topic of sortability, are there any other successes at Church & Dwight around circularity and packaging that you would like to highlight here?
Yeah, sure. Well, we're celebrating some successes in, especially in liquid laundry detergents. That's a big part of our business, and we've been reducing pack sizes and weights, like our liquid laundry detergent bottles, by concentrating the formulas. So that takes a lot of plastic out of our portfolio. And then we've been introducing PCR over the last few years. So that's now that's expanding beyond our liquid laundry detergent portfolio into lots of other areas. Now, how do we prioritize which ones to do first? Now it's being driven by policy, legislation that's being passed to say if you want to sell like household cleaners in Washington State, for example, by I believe it's 2025, you have to have at least 10 or 15% PCR in them. So we're now watching the space of policy and the laws that are coming through, and prioritizing a lot of our work based on what we have to comply with in order to avoid penalties. But certainly we're going far beyond that, even what's required, and introducing a lot more PCR than is required. So we're proud of the fact that we're on track for recyclability and PCR goals for our 2025.
Awesome. Thank you, Tina. So before you were mentioning a bit about this, you've got a label side of the picture, a cap, a bottle, and how you have to holistically think of how this will make it through the recycling system. So just wanted to let the audience know, actually, Tina and I first met at one of these sorting trials. So Tina was assessing some of their packaging to see what it would do in a recycling facility. So I just wanted to ask Tina, could you tell the audience a little bit about what those sorting trials are and why you from Church & Dwight are running them?
Yep. So since the list of problematic materials was released in January by the U.S. Plastics Pact, we as members of the U.S. Plastics Pact have committed to comply with that list. So we've identified materials within our portfolio that are they're on the naughty list now. So we were looking at some alternative materials. So we were doing some sortation trials to test those materials. So the first thing that you do for guidance when you know that you have a material that you need to get out of is you look at what are the best practice materials, let's say. So we would look at the APR guidelines on what do they say are meets preferred or critical guidance. And so we would start with those materials, but keep in mind the materials that the APR is saying they've approved or are recyclable is more from a reclaimer's point of view. So they can't necessarily say this is going to be recyclable all the way through the supply chain. It's up to us to test that it's going to make it through that sortation part, because my package is going to look different from one that's sold by P&G or a Unilever or an Avon. So our specific package we had to test at the optical sorter, or at the optical sorter manufacturer. So the reason we test also at an optical sorting manufacturer and not a MRF is because a MRF is essentially they're running production all the time. They've got all this material coming in. And it's really difficult for them to sort of get the resources to be able to count everything that's going through and see if it's getting sorted correctly. Everything moves so fast in a MRF, and you're going to end up losing some of your samples in all that volume of material. So that's why we test in more of a lab setting. It's more controlled. We go to the manufacturers of the optical sorting equipment. So that's where Brian and I met up. So the order of events might look like U.S. Plastics Pact releases their problematic materials list. So we, as a member company, we identify, okay, what do we have that we need to get rid of and replace with better, more recyclable materials? Then we engage with suppliers of those materials. We get samples made, and then we go to one of those optical sorting manufacturers and we schedule a trial. So as per the protocol, we have to put 20 samples of each variable through the optical sorter 5 times. And so if you think about it, that's 100 tries. Let's say if you do 20 samples 5 times, the hurdle is 95%. So 95 out of 100 times that bottle or whatever has to go through the optical sorter and get sorted as the correct material 95% of the time to avoid a detrimental to recycling status. Once we pass that hurdle, we can go to an entity like How to Recycle and say, hey, can you assign us a recyclability labeling to support our recyclable claim. So after all of that work is done and you've proven recyclability, you can make the claim, then it becomes a project within the company to actually implement that new material. Long process.
Thanks, Tina. Yeah, and just for the audience to wrap your head around when we're talking about optical sorting, so I want to talk a little bit about what that looks like and hone in here. So there's many pieces to the MRF, as I showed, you need to design around, but a big piece for plastics is that optical sorting. So when I showed our tool before, it's run by what's called near-infrared spectroscopy, which really is the same technology used by these optical sorters. So within a MRF, you see these automated sorting lines, and you might have something like this. So you'll have plastic coming through on a belt. It will run under an optical sorter. So same thing as what I showed in Alaska, just a much bigger and much more expensive version. It will scan the plastics coming through, use its technology to identify, for instance, this is a PET bottle, communicate that to a air jet sorter, which will then push it to the correct bin. And this is happening all very fast in real time. To give you a little sense of what that looks like, this is actually a video I took on my phone at that trial with Tina. So you can see in slow-mo here, plastic materials are going under that pulse light, which is the near-infrared spectrometer. It quickly identifies the material, and in this case, it kicks it to the far end if it is PET, and it lets it drop to the low end if it's not PET. So just to give you a little sense of what this looks like in person and what we're designing around. And then I wanted to explain what the issue can be. So we had mentioned in the beginning when we talked about the U.S. Plastics Pact that they had said a problematic material was carbon black pigmented. So carbon black is one of the predominant pigments used to get a black looking plastic. And so what will happen in this case, unfortunately, is that pigment itself can mask the polymer material in such a way that when it comes under this near infrared sorter, it really either doesn't see anything or it's not sure what it's seeing, and it will then just not sort it, and this will continue on to a landfill instead of getting correctly sorted and recycled. So even though this black PET bottle is recyclable, in this case, if it's not seen by a near-infrared sorter, it's not actually getting recycled, which is a huge issue here. And this is really where Trinamics came in. So we make a handheld version of what you're seeing here. And so it gives a little bit more power in the hands of people like Tina, people like Tyler, to actually look into these materials and see what their outcome will be in a recycling center. So I want to just hone in on black plastics, and I'll get a little bit technical here for those on the line that are interested. So black plastics is one of the biggest issues in this space, and it's well known. And the way I like to say it, it's a good analog to just our eyes. Near-infrared spectroscopy works very similar to how our eyes work. So if you look at this chip on the bottom left, it pretty clearly says, hey, I'm polyethylene. Now, if you look at data from a near-infrared spectrometer, without needing to know anything about this technique, basically this curve here, this data, is screaming to our instrument, hey, I'm polyethylene. The issue now with black is, even in this case with our eyes, if you put a black background with black writing, it gets very, very difficult to actually read what the writing is saying. And a similar phenomenon is what's happening here with carbon black. So the carbon black itself is such a strong absorber of light that it is just masking what's underneath. So you can see here this flat line on the top of the curve. Basically, that red curve is still under there saying, hey, I'm polyethylene, but this black curve over it from the pigment is masking that. And so you just aren't able to read anything. That being said, we always want to stress this isn't an issue with the color black. It's a pigment carbon black specific issue. So there are pigments out there, like I'm showing here in the middle, that really don't disrupt this underlying curve. And so they're black, but they're still screaming out to the technology, hey, I'm polyethylene, please recycle me in this bin. And so this is really where this topic came at hand. Is you can see this data was captured on our Trinamic system, and it serves as a guide so that instead of people like Tina needing to go and shut down an optical sorter and spend a lot of money to find out whether or not this makes it through, you can really use our device right here to get a sense of that. And so that's what I wanted to bring the question over to Tina and ask, as the final face behind the product from Church & Dwight, curious how this topic of sortability has affected your brand. Who is making note of it, that if you put out a black plastic or a problematic label, that it's not being recycled?
Yeah, this is a great question. So brands love, CPG companies love carbon black because it's the least expensive black by far, and it gives you a really jet black, nice black color. And if your brand identity is linked to a black color, that's like your go-to. So what I came up with is, when I've tried to explain the challenge here, is there's a triangle of trade-off. Okay, so when you bring recyclability into it, so you've got that jet black color that you really want at the top of the triangle, right? But if you want it to be recyclable, like what Brian was talking about with using carbon black, it's not going to get picked up by that optical sorter. So, but there is this technology of this near infrared black colorant that is detectable. So we call it NIR detectable black pigment. So in order to make those recyclable, you have to use these NIR detectable pigments, but they cost a lot more than carbon black. So you see the conundrum there as a brand owner. I really want recyclable and I really want the jet black color, but I don't want to pay more cost. So a lot of times brand owners they're faced with, okay, if I can only have two of these, which ones do I choose? And if you, like I said, if you have your brand identity linked to that black color, it's been a really big challenge. I've actually had talked to marketing folks to say, okay, what if we went to like a really dark gray color, so that we didn't have that, issue with the recyclability, and we wouldn't have to pay for near infrared detectable colorants. And they just, most of the time, if your brand identity is linked to black, it's just, gray is just isn't going to cut it. So it's just a conundrum, and it's a hard choice that companies have to make, but we can't have all three with the current technology as it is.
Yeah, thanks for sharing that, Tina. I do want to turn it over to the topic of labels now as well. So labels are another topic that we mentioned are been marked as problematic. Labels are a material to watch out for by the plastics pack. And so if we look at labeled plastics, when we're looking at things like full shrink sleeves, like you're seeing in this picture, this can have issues in sortation for a different reason, but somewhat similar. And so if we're looking at a package, you've got the container itself, so high density polyethylene, this is what you want to recover. There's a lot of material there and you can pull from it. the label itself is much lower recovery value. It's much thinner, it tends to be multi-layer, not a good economic option for it afterwards. And so when you consider a labeled container, what you're really trying to capture is the container itself in our recycling infrastructure and less so the label. And so if we look again to some data from a near-infrared spectrometer, this bottle here screams out to near-infrared systems, I'm HDPE. And if we put a preferred label on top of it, what we would call a near-infrared transparent label, what you're seeing here is that purple curve on the bottom is just the label itself, and the blue is the bottle plus the label. And just note that the blue and the green line are pretty close to the point that you could say the label itself is having a pretty minimal impact on the container. So even though it's there and it's PET, near-infrared systems still clearly read, this is HDPE, and I'll sort it that way. The issue is a lot of labels out there don't work this way. And so problematic labels come into play here, where now you can see that purple line, much higher absorbent level, and that blue line actually looks exactly like the purple line. And so what this means is if this goes under an optical sorter, it's going to see, hey, I'm PET, push that to a PET bin, and basically you're losing all of that HDPE that could have been recycled through this missort. And so this is where that problematic labels topic come into play. So kicking the ball over to Tyler, as a label brand, I'm sure problematic labels is a topic very close to home. So can you tell me a little bit about how this has affected Brook & Whittle and what your customers are asking about this?
Yeah, it's a great question. I'd say for sure, it's 100% of our customers are asking about this. I've personally been involved, just focusing on the plastics for right now. I've personally been involved with APR and so have many of my colleagues at Brook & Whittle for quite a while now. And it's an area we've put a ton of resources towards understanding the guidelines, even helping further develop them, creating solutions that benefit the recycling system, both in a MRF environment and in the reclaiming environment as well. So, just some examples of that has been, the switch from PETG shrink sleeves or even PVC shrink sleeves on PET containers to crystallizable PET shrink sleeves with de-inking technology, or in the case of pressure sensitive labels, moving, towards non-removable adhesives to friendly wash-off adhesives. And again, this is work we've been doing for nearly a decade now. And most recently, we have seen a need to remove colored or opaque PET from the recycle stream, as it's not widely recycled and it is really cost prohibitive to recycle. I know you kind of mentioned the black plastics as well, but obviously being called out in the U.S. Plastics Pact that opaque and pigmented PET is problematic and unnecessary. So with that in mind, we recently developed a sortable and recycle-friendly light-blocking shrink sleeve that allows the brands to switch to clear PET that are more valuable in the recycling stream and have a higher yield towards PCR content into new PET containers. And again, that's just on the plastic side. We've kind of seen similar concerns with labels and have made innovations to address other packaging formats, whether that's paper packaging, aluminum, which is a tricky one, and flexible packaging as well, of course, with mono polyethylene films and including recycled content and things like that in those formats. But all areas that we've put emphasis to understand and develop as well.
Great, thanks, Tyler. So I wanted to kind of wrap up this topic where we really honed in on black plastics and labeled plastics and how they can impact recyclability. But we needed to kind of do more than just have, the three of us in our working group discussing this. And so we had mentioned a few times the Association of Plastics Recyclers, or the APR. So the APR is a pretty well-known figure in this space, and they've got this critical guidance set of methodologies to really assess whether or not you're using materials that will be correctly recycled and will be then recyclable after the fact. And what I'm just showing here is what their protocol for assessing the sortability of your plastic product is. And so this is called APR Sort B01. And you can see it's quite complex. You get a lot of the same product, you compress it in a certain way, you put it on a belt with a lot of other waste, you run it through an optical sorter multiple times, and you see, as Tina had mentioned in the past, you see basically whether or not 95 out of 100 of your bottles make it through. And if they do, you're deemed recyclable. So you can imagine doing this is quite time consuming. and also cost consuming. And so that's where we really came in about a year and a half ago. Trinamics had worked with the APR on that topic of black plastics. And basically they used our device and benchmarked against different optical sorters out in the field and came up with a standard methodology of what they called this SORT SO1 snap test. So just a simple measure your pigmented plastic with near infrared and see whether or not it has enough reflectance to even be seen in a MRF. So we were able to automate that in our app system to just give a binary yes or no, pass fail answer to package designers who are now using our device to assess their black pigments in lab instead of having to shut down a sorting line every time they want to find out. And Tyler, Tina, and myself are really the kind of leads on this labels topic now at the APR. So we're working to create a similar snap test because labeled plastics are a much more complex topic than just the black, but we are really honing in towards a solution. And the goal here is to provide as much guidance as possible and to democratize this type of technique so that more packaging designers, more CPGs can determine earlier on that their packaging has an issue or it doesn't have an issue, so we can really make sure everything that's going out into the world is designed for circularity, which really is the point of this whole talk. So quick question for both Tina and Tyler to finish this out, and maybe I'll start with Tyler, is how do you see this work? So the work we're doing together with the APR, impacting the recycling industry as a whole and impacting your business?
Yeah, hopefully for the betterment, right? And I kind of give an overview of what you showed earlier, but I've obviously visited many MRFs and plastics and paper recycling facilities as well. And again, they all operate a bit differently, but understanding those material flows, the NIR equipment, what hand pickers are looking for, size requirements, 2D, 3D, metal detection, eddy current, all these other nuances of a MRF environment to sort out our materials has been very helpful for me, but also the companies that I've worked for in developing those solutions that are, again, effectively sorted to their proper bales. And then, of course, once they're baled and sent to the various recycling locations, we have to then understand how they further sort or grind, wash, remove contaminants, byproducts. And this kind of all leads back to that initial design phase that I talked about in that holistic view, and just really how important that step truly is. So again, what you've mentioned, but the work that the three of us are doing on that APR work group will hopefully lead to some decreased time and cost and analyzing whether packaging will sort properly in these recycling environments. So hopefully we'll have more information to share on that here in 6 months to a year's time, depending on how we go with the testing and data. So yeah, thanks.
Thanks, Tyler. Yeah, let's hope closer to the 6 month time, but we know how research goes. So Tina, same question for you. How do you see this impacting the recycling industry, but also Church & Dwight?
Yeah, we absolutely need more detailed guidelines. Right now, it's kind of the obvious and the general guidelines that we know what's recyclable and not recyclable. It's easy to design around those, but then you start to get into a lot of nuance when you're getting into like specific types of decorations or metallizing or colorants that have pearl in them. Then you start to get into these gray areas where the APR doesn't have any direction. So we have to dive deeper, and then we end up paying thousands and thousands for this, testing all of these different, scenarios. So absolutely what Tyler said, saving cost on all of those trials and speed to market, saving time. If this work has been done in a methodical way, by our team, and we have some really good guidelines, that's going to allow companies to skip, a whole lot of redundant work and save a lot of time. So, and I think with the Trinamics, there's a huge opportunity there, because if we have that testing in-house and under our control, and I'd like to at least get an idea up front. I mean, it doesn't replace optical sorting, the final test, but it gives us some direction. And if we have that under our control and we can get those that feedback quickly, that's really going to allow us a lot of, design, freedom, and it's going to allow us to move a lot more quickly.
Thanks, Tina. Yeah, I really appreciate that answer. And yeah, just to wrap things up, I wanted to just focus that what we're talking about today is one small area in recycling. So we're talking about plastics recycling specifically, and then optical sorting in plastics recycling. But you can imagine there's many more topics here that need to be addressed to really bring up our recycling rate. But I hope it was useful to see how different stakeholders are coming together, and the amount of work and thought that really goes into just one piece of the puzzle. So really hoping other people on the line are inspired to find their own multi-stakeholder groups and try to pull together another way to tackle a recycling issue like this. And so I know we're low on time. I wanted to get to a couple Q&A very quickly. One that really struck me that I just had to come out and say, so there was a question in here, and I hear this all the time from friends, is really around kind of, is recycling even real? There's an article 5 times posted a day about how recycling is fake. I can unequivocally say I've been to many MRFs across the country. It is real, it is happening. It is very complex, as we showed, and it could use help on making streams less complex. But could it work better? Absolutely. But from a starting point, these doom and gloom articles that say recycling isn't real, just don't do it, the alternative is a landfill. And so I really, really say none of this work we're doing will matter unless it's making it to a recycling bin. And so I know there's reason for trust to be shaken, but we really need to have people believing in recycling, believing in the work we're doing, for this to actually raise recycling rates and come through. So had to just get that out there really quick. Another question I want to put to Tyler, because I thought was pretty interesting too, was can you talk a little bit more about how labels are currently being recycled, or if they are being recycled, and what that process looks like?
Yeah, thanks. I saw that question as well. Just to give you an example on the PET side, and I kind of mentioned this earlier, but again, using those different label solutions that are designed for that system. So whether it's a wash-off adhesive or a crystallizable PET, the labels that are removed, say pressure-sensitive labels, wrap labels, things like that, unfortunately, a lot of them are landfilled. I know that some are sent waste to energy, and then I think some are even recycled where markets exist anyways. But this is actually something that the APR work group, a different work group within the labels work group, is going to look at this topic in a little bit more detail to get some better data on this from the reclaiming facilities, just to understand what's actually happening to those removed materials. No caps, for example, are typically recycled. On the other hand, the crystallizable shrink sleeves are intended to be recycled with the package, assuming they make it past all the sortation steps, which they're designed to do, as well as then if they make it past deblutriation, they're designed to be recycled alongside the bottle. So in that case, that's kind of the best case scenario.
Thanks, Tyler. So we've got a lot of other questions in the chat, so we do want to let the audience know we will get a copy of these questions and reach back out. Unfortunately, we are running out of time, so a lot of great content here. We'll just pass it back to Ben to close us out, but really want to thank everyone for joining today, and really big thank you to Tina and Tyler for joining in and all of the work they're doing on this project as well.
Great. Thank you, Brian. Thank you to Tyler and Tina for participating today. We very much appreciate your time. There's the amount of time you spend today, and there's obviously the preparation for this. So your commitment is highly appreciated. The more I hear about packaging, the more I realize how complex it is, right? We were talking about the bottle, we're talking about the label, we're talking about multi-layer packaging. It's just so complex, and I really like and am encouraged by the fact that we have now technology that can start to see and understand these things a little bit better. And thank you, Brian, for answering the question on recycling. Yes, I've been to MRFs as well. It is happening. It is real. Please continue to do so as much as you can. So I think that's very important. So yeah, thank you to our audience members for attending this morning's session, this first session of today. Yeah, I think it was very exciting. I think we covered quite a few topics. You walked the fine line of technology very well, Brian, Tyler, and Tina. So I know I learned some new things, but hopefully our audience did as well. So for our audience members, Brian already mentioned the issue with time and questions, never enough and always too many. And that's we do appreciate your questions. We do have quite a few. It was a very engaging discussion, we will respond to those questions afterwards. So thank you for submitting those, and thank you for your interest. I would also ask you to please don't forget about our survey. So that icon on the bottom far right-hand side, if you click on that, some very basic questions. So please answer that, and we would very much appreciate that as well. So we're right at the top of the hour. So thank you once again for everyone that participated. Please tune in. Actually, right in an hour, we have our afternoon session also on plastic circularity coming up. So if you can, please attend that as well. And I think with this, I'll wish everyone a safe and sustainable day, and on to the next. See you at the next one. Thank you all.
Thank you.